here we go. 3.6a, curve sketching. So we already know x and y intercepts. How do you find an x-intercept? Substitute in 0 for y. How do you find a y-intercept? 0 in for x. All right, I'm not worried about symmetry. Domain, when things break. All right, continuity, vertical asymptotes. When do you get a vertical asymptote? Number over 0. We're going to take derivatives. What's a relative extreme? How do you find a relative max? F prime changes from positive to negative. What makes a relative min? F prime changes from negative to positive. Those only happen at what numbers? Critical numbers. Concavity deals with what? The second derivative. How do you get a point of inflection? Okay, what needs to happen in order to get a point of inflection? The concavity changes sign, exactly. And then horizontal asymptotes and limits to infinity, those are the same thing, all right? So there we go. Let's put them into practice. I'm not worried. Here we go. So we're going to analyze this graph. So we're going to have x squared minus 2x plus 4 over x minus 2. We're going to find the first and second derivative. We're going to find the x-intercept, the y-intercept, the vertical asymptote, the horizontal asymptote. Critical numbers, p-poise, and our test intervals. All right. All right, let's do things that don't require calculus first. That's kind of the way I like to go about it. So how do we find an x-intercept? Substitute in 0 for y. So I said 0 equal to x squared minus 2x plus 4, right? What do I like to do with quadratics? F them up. It doesn't. All right, good. So do I have any x-intercepts? No. Y-intercept, what do? We substitute in 0 for x. So what do we get? -2. So we have a y-intercept of 0, -2. A vertical asymptote. When do vertical asymptotes occur again? Number over 0. So what number is going to do that? 2. So I get x equals 2. Now for horizontal asymptotes, I need to take a limit as x approaches -infinity and a limit as x approaches infinity. So when x approaches -infinity, where's my higher power? The top. So what do I get? I get -infinity. All right. And then if I substitute in infinity, what do I get? Positive infinity. All right, but technically, do I have any horizontal asymptotes? No, I don't really have any. All right, that was our pre-calc, or algebra 2 part of it, or algebra 1. Now, we need to get to our first derivative and critical numbers and stuff. So, let's take a derivative. What rule do we have to use? Quotient rule. All right, what's the derivative of my top? Times the quantity minus the derivative of the bottom is 1 times all over all right, so on this first portion on the left of my numerator, I need a FOIL. So what does that FOIL out to? 2x squared, and then minus 4x, and then minus 2x, so that's minus 6x, and then what? Plus 4. Then what should we do with this -1? Pew! Pew, pew, pew. All right, does anything happen? 4's cancel. Pew. All right, so how many x squareds do I have? I have 1x squared, and then what? Minus 4x over x minus 2 squared. Now, I personally would like to go a little further in order to write my first derivative, because I need to find critical numbers. So what should I do with my numerator? Factor out an x. So then I have x and then x minus 4. So what are we going to do with that when we set it equal to 0? We're going to find critical numbers. So when I set it equal to 0, what do I get? I get x equals 0, and I get x equals 4. All right, those are my critical numbers. What might happen at those critical numbers? Relative mins and maxes might happen. All right, but my first derivative, I'm going to say, is x times x minus 4 over x minus 2 squared. All right, now I need to get to p-poise. So what we need to do, take a second derivative. Now, I'm going to take a second derivative using that one, okay? So I don't have to do a product with a quotient. Does that make sense? All right, so let's take a second derivative now. So f double prime, what's the derivative of my top? 2x minus 4 times the bottom of x minus 2 squared, and then minus, what's the derivative of my bottom? 2 times x minus 2 to the power of 1. And then times the top of x squared minus 4x. All over x minus 2 quantity to the what? 4th power. Now, what I would advise doing is, you see how I have x minus 2 quantities everywhere? We're going to get rid of one of them. All right, it's going to make your life a little bit nicer. So I'm going to get rid of that one. This power goes to a 1, and then that power goes to a 3. All right. All right, so what do we have to do with that left side of our numerator again? We're going to FOIL it. So what does it FOIL to? 2x squared, and then minus 4x, and then minus 4x, so minus 8x, and then plus 8. And then I'm really distributing a negative 2. So now what happens? I get a negative 2x squared, and then plus 8x over x minus 2 cubed. Does anything lovely happen? 2x squareds cancel, and the 8x's cancel. That is nice. All right, so what do we get? 8 over x minus 2 cubed. Pretty good. So that's my second derivative. So I have 8 over x minus 2 cubed. Now, to find a p-poi, we try to set that equal to 0. Can I set that equal to 0? No, nothing's going to happen with our x value. So do I have any p-pois? No, I got none. Now, let's do our test intervals. So we're going to start from negative infinity. And then what?
To 2.
Not to 2 yet. To 0. It's my critical number. And then I'm going to go from 0 to what now, Tristan? 2. Why 2? Okay, that's my vertical asymptote, and that's my domain issue. Yes, it's all the same, I guess. All right. And then I go from 2 to 4, and then 4 to infinity. All right, let's do our tests. So I'm going to have my test intervals. Negative infinity to negative, what was it? To 0, I'm sorry. And then I'm going to test x equals 0. And then I'm going to go from 0 to 2. And then I'm going to test x equals 2. And then I'm going to go from 2 to 4. And I'm going to test x equals 4. And then I'm going to go from 4 to infinity. All right? And I want to see what's going on here. Now, what do I know x equals 2 is doing? That's a vertical asymptote. So I'm not going to have an f or an f prime or anything like that. That's a vertical asymptote right there. So I'm going to sketch that first. So I have a vertical asymptote going on. Now, do I have a horizontal asymptote anywhere on this one? No, I don't have that. All right. So here we go. So negative infinity to 0. What is my f prime? If I substitute in like negative 1 into my first derivative, I get a what? I get a negative and then a negative over a positive. So that means it is positive. Now let's substitute in like negative 1 into my second derivative. So I get a positive 8 over a negative cubed. So I have a positive over a negative, which makes it a negative. All right. So what does that mean? If I have f prime is positive and f double prime is negative, that means f is increasing and concave down. Now, I want to do 0. So let's look at 0. We already substituted it in. What did we get? 0 comma what? Negative 2. All right. Now, we already did the f prime of that. That's how we found it's a critical number. So what's f prime? 0. Now let's substitute in 0 into f double. So I have 8 over a negative 2 cubed. So I get a what? A negative. Exactly. So what's happening at x equals 0? Use your hand. What do I got going on? A relative max. I have a relative max going on. All right, let's keep going from 0 to 2. So now let's pick 1. So let's substitute in 1 into my first derivative. So I get 1, so a positive, times a negative. So I end up with a negative. Now, what's it going to do when I substitute in my second derivative? Positive over negative, which is a negative. So f is decreasing and concave down. I want to graph that left side for us, okay? So at 0, what's my f value? Negative 2. So at 0, I'm at negative 2. And then, this is like your complete hand pretty much. If f is increasing and concave down, if you're using your left hand, that would be like your thumb. You see how that worked? See how it's going up and then it's concave down right there? So it should look like that. And then from 0 to 2, it's going down and what? It's concave down. All right, so f prime is negative and f double prime is negative. So that should look like your hand like that. All right, so it would look something like that. See how that worked? All right, let's keep working. So we go from 2 to 4. So let's substitute in something like 3. So in my first derivative, I'd get a positive times a A negative, which means f prime is negative. And then let's substitute in your second derivative. So if I substitute in a 3, I'd have 8 over a positive, which means it's positive. So what's f doing? Decreasing and concave up. All right. Now, we haven't substituted in 4 yet. So let's substitute in 4 into the original. So we have 4 squared, which is 16 minus 8 plus 4. So we're left with 12. 12, right? No. 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 Oh. All right, let's do that again. We're at 6. We're at 6. All right, good. Oh, over, I'm sorry. So we'd have 12 over 2. So we get 6. All right. I'm sorry, guys. So we're at 6 now. And then what's my f prime? We already did the work there. It's a critical number. So what's f prime? 0. And then what's f double prime? Let's substitute in 4. So we'd have 8 over a positive. What's going on here? Use your hand. I have a critical number. I'm concave up. What's happening? It's a relative min. All right, 4 to infinity. So let's substitute in something like 5 into my first derivative. What would my first derivative be? Positive or negative? Positive. What's my second derivative? Positive. So f is what? Increasing and concave up. All right, so at 4, we're at 6. And on the interval 2 to 4, I'm decreasing and concave up. And then I'm increasing from 4 to infinity and concave up. So it should look like that. All right, you see how useful your hand is right now? All right, so we're like something like that. Pretty good? All right, let's see how we did. We did excellent. All right, pretty good? All right, let's do another one. You might want to start a new page. So we're going to sketch the graph of this one. So now we have 2 times x squared minus 9 over x squared minus 4. So again, I like to start out with my pre-calc. So let's find an x-intercept. How do we find an x-intercept? Substitute in 0 for what? Our y. So I have 0 is equal to basically my numerator. What would I probably do with that numerator? I'd factor it. All right, so let's factor it. 2 times what? All right. I'm just going to factor the bottom 2 while I'm at it. What's the bottom factor 2? Good. All right, so what are my x-intercepts? 3, 0, and negative 3, 0. All right, y-intercepts. What do I substitute in? 0 for y. Oh, 0 for x, I'm sorry. 0 for x. So if I substitute in 0 for x, I get 2 times 9 up top, which is negative 18 over negative 4, which can simplify to what? 9 halves. All right, so my y-intercept is 0, 9 halves. Vertical asymptote. How do I get to a vertical asymptote? Number over 0. When do I get it? X equals 2. and x equals negative 2. Horizontal asymptotes, what do we look at? Limits to what? Infinity and negative infinity. So my limited infinity, I look for my higher power. What are they? Same. So what is it? 2. If I do a limit to a negative infinity, guess what it is again? It's still 2. All right. All right. There's my pre-calc or algebra 2 part of it. Now, how do I get to a critical number? What do I need to do first? Take a derivative. All right, so let's take a derivative. What rule do we have to use again? Quotient rule. Now, yesterday people struggled with this. If you want, you could think of this as like 2x squared minus 18. Like if you wanted to, it might help you out a little bit. All right. All right, what's the derivative of my top? 4x. Times, times the bottom of x squared minus 4. Now, what's the derivative of the bottom? 2x. Times the top of all over x squared minus 4 squared. All right, let's combine like terms after we distribute. So when we distribute, we're left with 4x cubed minus 16x, and then minus 4x cubed, and then plus 36x, all over x squared minus 4 squared. Does anything lovely happen? I love that when it happens. All right, so what's left up top? 20x, that's good. So we get 20x over x squared minus 4 squared. Are you guys starting to get excited when things cancel? I know, it's so lovely. All right. So we have 20x over x squared minus 4 squared. So what am I going to do with that first derivative? I'm going to set it equals 0. And so when I set it equals 0, what's my critical number? X equals 0. All right. All right. Now what do I need to get to? My second derivative. What rule do we use again? Quotient rule. So what's the derivative of my top? 20 times minus, here we go. What's the derivative of my bottom? What comes out front? 2. And then x squared minus 4 to the first, but then what pops out? 2x. Guess what sometimes students forget to do? Chain rule. Don't forget chain rule. And then times 20x. All over x squared minus 4 to the power of 4. What would I highly suggest you do right here? Cross out one of the x squared minus 4s. So this one, go bye-bye. That one goes to a 1, and this one goes to a 3. All right, so let's distribute and start combining. So f double prime. So distribute my 20x, or 20, so I get 20x squared minus 80. And then I have a negative 2, a 2x, and a 20x. So what does that become? Negative 80x squared. All right. All over x squared minus 4 cubed. All right. I'd like to go a couple more steps before we just write that one. So that becomes what? Negative 60x squared, and then minus 80 over x squared minus 4 cubed. What could I factor out of that numerator? I would go a little bit more than just 20. I would factor out a negative 20. So if I factor out a negative 20, I'm left with 3x squared, and then what? Plus 4. Now, I'm going to try to find p-poise. So if I try to find p-poise, I set that equal to 0. Do I get anything? No, not in the real number system, so I don't get anything. Because this is always going to be what? The 3x squared plus 4 is always going to be what? Positive. It's always going to be positive. All right, so that's why I'd factor out the negative 20. So that numerator is really always going to be what? Negative. It's always going to be negative. All right. All right, so there's my second derivative. So I have negative 20 over negative 20 times 3x squared plus 4 over x squared minus 4 cubed. So no p-poise. So what are my test intervals? Negative infinity to what? Negative 2, and then negative 2 to 0, and then 0 to 2, and then 2 to infinity. Let's set up our chart. So now we have negative infinity to negative 2. We're going to test x equals negative 2. Actually, what is x equals negative 2? Vertical asymptote. And then I'm going to go from negative 2 to 0, right? And then I need to test x equals 0. And then I'm going to go from 0 to 2. And I need to test x equals 2. And then I need to test 2 to infinity. Now, what is x equals 2 again? That's our vertical asymptote. This is where I also like to do my x-intercepts and my horizontal asymptote. All right, so we know that from our previous page. So what was my x-intercepts? Negative 3, 0, right? And 3, 0. And what was my horizontal asymptote? Wasn't it 2? So y equals 2. All right, let's start making our little chart. So if I substitute in something on the interval negative infinity to negative 2, like, I don't know, negative 3, so what would my f prime be? Actually, look at f prime. We got 20x over something squared. What's the denominator always going to be? Positive. So if I substitute in something negative, what's f prime going to be? It's going to be negative. So this one's going to be negative, and that one's going to be negative. You following me? Let's just do f prime the whole time on this one. If I substitute in 0, what do we get? We get 0. Okay, it's a critical number, right? If I substitute in something positive, it's going to be what? Positive, right? You see how we just worked with that real quick? All right. All right, now let's work with our second derivative. What's the numerator always going to be? Negative. Then the bottom, the denominator, that's going to change. So if I substitute in negative 3, is that going to be positive or negative on the bottom? It's going to be positive because it's greater than 4. So what do I get? I get a negative because I have a negative over a positive. So what does that mean for f? F is what? Decreasing and concave down. So show me with your hand. What does it look like? Like that, right? Now, which one is decreasing and concave down? Your fingers or your thumb if you're looking at it like that? Your fingers. Your fingers. So that's what that part's looking like. All right. So on that part, it's looking like that. All right. You see how it's decreasing and concave down. All right. All right. Let's do the next interval. -2 to 0. So what is f double prime? Positive or negative? Positive. I already substituted in 0. What was my f? 9/2, 9/4, what was it? 9/2. Now if I substitute in 0, what would be my f double prime? Got a -20 over a negative cubed. So I'd have a negative over a negative, which makes it a positive. So what does that mean at x equals 0? What do I have going on here?
Concave up.
It's concave up, which means I have a what?
Relative minimum.
Relative minimum. All right, I have a relative minimum going on. And then let's finish up that part of it. So 0 to 2, like 1, my concavity would be what? Positive. All right. So if I were to graph that part, it's concave up the entire time. My f prime is negative, and then my f prime is positive. So it should look just like that for your hand. All right. So we make this little U going on like that. All right. Pretty good? All right, let's finish this up. So 2 to infinity, like let's substitute in 3. So if we substitute in 3, positive or negative? I have -20 over what? Positive. So I have a negative. So that means it's increasing and concave down. So my hand's looking like this. Which one is increasing and concave down? The thumb or the finger? The thumb. All right, it's looking like that. So I would finish it up just like that. All right. Let's see how we did. Oh, we did actually. All right. Pretty good. All right. Page, what was it? I think it was like 216 or something. I want to say it's 216. 215. So page 215, I want you to do numbers 1 through 4. Those will be very quick. Those are not like what we just did. I want you to do 6 and 8. On 6 and 8, I want you to do it the way we just did. Okay? So really, I'm kind of giving you 2 problems. Okay? 2 problems.